Welcome. So today we are going to start another topic, which is flame photometry. Before starting flame photometry, let us see what is flame test. We know that whenever a sample of alkali or alkaline earth metal salt is shown in Bunsen flame, non-luminance flame, what will happen is that a characteristic color is in the flame is found. Okay, so a characteristic color is produced to the flame, and that is because of the emission of radiation. And this experiment is known as flame test, has been used for many qualitative analysis of metallines and comes under atomic emission spectroscopy, also called flame atomic emission. What I mean to say that, say if a if a alkaline or alkaline earth metal is presented into a flame, non-luminous flame, so what will happen that you will see that there is a definite color that is imparted to the flame. So here we can see for potassium, emitted wavelength is 766 nanometer, and then the color of the flame will change to blue. So lithium, we have 660 nanometer, and the color will change to red. Calcium, we have emission wavelength of 622 nanometer, color will change to orange. Sodium, we have emission wavelength of 589 nanometer, color will change to yellow. Barium, emission light 554 nanometer, color will change to lime green. So this is the meaning that this is a flame test, and this is used for the qualitative determination of alkaline earth metals, especially in the flame photometry. Okay, so what is flame test? So whenever an alkali or alkaline earth metal enters into a non-luminous flame, it will impart definite color to the flame because of the emission of characteristic radiations from it. So this is the flame test, and it is used in flame photometry to determine the concentration of alkaline and alkaline earth metals. So what is the theory? That in this method, the analysis of light emitted by the substances that have been brought into excited state in the flame is measured. So you know that you have atoms, so molecules will be there, that molecules will be converted to atoms, and atoms will get into excited state, and when they come back, they will emit radiation of the characteristic wavelength. So when a salt of alkali or alkaline earth metal, sodium chloride, is placed over a non-luminous flame. So what is the meaning of non-luminous? Non-luminous means that the flame which is blue in color, having sufficient supply of oxygen, blue in color, and then it is more hot and less light producing. So it will be less light, it is blue in color, more oxygen, and more heat and less light will be given by non-luminous. And its opposite is luminous flame, which is yellow in color. There is insufficient supply of oxygen, and it will give less heat and more light. That is the meaning of luminous flame. And here in this we make use of non-luminous flame, where oxygen supply is sufficient. So when a salt of alkali or alkaline earth metal, sodium chloride, is placed over a non-luminous flame, the salt decomposes into atoms or ions of the constituent elements. Now if the temperature of the flame is sufficiently high, some of the metals atoms may absorb energy to pass into excited state, while the others will remain in the normal or ground state. Okay, so if the temperature of the flame is sufficiently high, some of the metal atoms may absorb energy to pass on to an excited state, and while the remains in the normal or ground state. So the activated atom will drop back to the ground state with the emission of photon or radiation. So such radiation is the characteristic of the element and measured with the help of flame photometer. So we can measure it by the flame photometer. So when the atom comes in the ground state, the characteristic radiation will be emitted, and that we are measuring the intensity of that radiation being measured in the flame photometer. So this is the schematic diagram of flame photometer. We can see that here liquid sample will be aspirated, and then through air and fuel it will enter into the flame, and then excitation will take place, and by filter we will so this is a filter. We will select the specific wavelength of interest, and that will be measured by the detector. The intensity of the light which is emitted from the elements of interest will be measured by the detector. So steps here again are the same. So what are the steps? First, there will be aspiration, that is your solution will get into the small droplets, and then there will be a desolvation, that is a removal of the solvent will be there, and there will be solid analyte particles will be there, and then there will happen voltization, that your analyte particle will get converted to gaseous state, and then there will be atomization, that molecules will get converted to atoms, and these atoms on more energy, that if more energy will they get excited, and they will some of the atoms get excited, and when they come back to the ground state, they will emit energy of the characteristic wavelength. So these are the steps which are involved in atomization. So this is the atomization process in flame photometer. The same way is there in the atomic composition spectrophotometer also. So steps are your first is aspiration, then desolvation, voltization, and then atomization, excitation, and then there will be emission. Okay, so since there is very fine capillaries used to dose sample into the flame, therefore the sample must not contain big solid particles. बड़े solid particles नहीं होने चाहिए, नहीं तो वो ब्लॉक करेंगे कैपिलरी को. ठीक है, तो इसलिए आपके जो है सैंपल में जो पार्टिकल्स जो है वो बड़े नहीं होने चाहिए. और फ्लूइड मिल्क के केस में और ब्लड के केस में हम डाइल्यूट सैंपल को भी यूज़ कर सकते हैं। और अगर हम सॉलिड प्रोडक्ट्स की बात करें जैसे चीज़ है, खोआ है, चना है, तो इनको हमें ऐश में कन्वर्ट करना पड़ता है और ऐश को हम डाइल्यूट एसिड सोल्यूशन में डाल के उसको फिर हम जो है एस्पेरेट कराते हैं। और हमें ये देखना होता है कि जो कंसंट्रेशन है मेटल के डाइल्यूट सैंपल में वो 5 से 10 ppm के बीच में रहे, तो ही हमारा जो है रिजल्ट्स जो है कैलिब्रेशन कर्व के अंदर फॉल होते हैं। ठीक है, सो द कंसंट्रेशन ऑफ द मेटल इन द डाइल्यूटेड सैंपल में बी इन द रेंज फ्रॉम 5 to 10 ppm. Okay, now just to tell you how to prepare Stokes standard solution, this there is another video on this, but just quickly tell you, if you want to prepare 1000 ppm solution of sodium, simply we have to divide the molecular weight of sodium chloride from sodium chloride 58.5. So if you divide 58.5 divided by the 23, we will have 2.539 gram NaCl. Okay, so if this gram NaCl you dissolve in 1 liter of water, you will have 1000 ppm the solution. This is very easy. I told you how to calculate it. So if you want to prepare 1000 ppm solution, so if you want to prepare 1000 ppm solution, wait, just so if you want to prepare 1000 ppm of solution, so 1000 ppm of solution equal to mass of solute. How much mass of the solute today कितने वो आपके कितना वॉल्यूम में बनाना है, 1000 वॉल्यूम में बनाना है into 10 power 6. Okay, so you will see that mass will come 1 gram. So if you want to prepare a 1 gram sodium, that 1 ppm solution, that if you want to prepare 1000 ppm solution of sodium, then you have to take 1 gram of sodium, and 1 gram of sodium will come from 2.539 gram of NaCl. Okay, so this way if you're taking this much gram of NaCl in 1 liter, make up the volume to 1 liter, you will have 1000 ppm solution. Similarly 1.911 gram NaCl if you take and make up the volume to 1 liter, you will have 1000 ppm solution of the potassium. Okay, so then standard solution can be diluted to give working solution of 10, 9, 8 ppm, because we have to draw the calibration curve, and potassium as 543 ppm respectively. Now say from 1000 ppm solution how to dilute it. So you know that here we have 1000 ppm solution. If we take 10 ml, make up the volume to 100 ml, you will have 1:10 dilution, and then we will have the solution of 100 ppm. And then from that, if you want to take 10 ppm sodium and 5 ppm potassium, then you take 10 ml of sodium and 5 ml of potassium, make up the volume to 100 ml. Similarly 9 ml of sodium and 4.5 ml of potassium, make up the volume to 100 ml. 8 ml of sodium to 4 ml of potassium, you make up the volume to 100 ppm. You will have 8 ppm sodium and 4 ppm. So for milk sample, what you have to take, you take 5 ml of milk, make up the volume to 50 ml. Again from this you take 5 ml and then make up the volume to 50 ml. So dilution total will be 1 by 100. So dilution will be total how much? 1 by 100. Okay, so this why we are diluting the sample to 100, because by doing so we will have the range which we want, say 5 to 10 ppm of the sodium potassium will be there in the sample. So that way we have to dilute to 1 by 100. Okay, so sodium and potassium salts are used in neutralizer. So what is the significance? What is main purpose of using flame photometer? That if there is adulteration by neutralizers, because neutralizer is added in the milk to neutralize the acidity that has been produced in the milk, and commonly used neutralizers are the sodium hydroxide, sodium carbonate, and sodium bicarbonate, and presence can be detected by estimating sodium potassium in the milk and milk products. So if you see that, we know that the sodium content in buffalo milk ranges from 45 to 55, whereas in cow milk it ranges from 50 cow milk ranges from 50 to 60 milligram per 100 ml. Okay, similarly if you see the potassium content, so it is 100 to 120 milligram per 100 ml in buffalo milk, and 140 to 150 milligram per 100 ml in cow milk. Now the concentration of these metal, if it is in the above than this range, it's obvious that neutralizers are added. So if the range of the sodium and potassium are above that above of the normal range which is there in the buffalo and cow milk, then we say that the milk is adulterated with neutralizers. Okay, so this is the most important important application of flame photometer in which we can determine the addition, the detection, in which we detect the neutralizers present in milk. Okay, so if we compare the flame photometry and AAS, so flame photometry is based on emission, and AAS is based on absorption. That we know. The radiation emitted from the flame is measured, and in this case decrease in the intensity of the radiation from the hollow cathode lamp to absorption by atoms in the flame is measured. So in this we are making use of hollow cathode lamp. The additional source is there, and then when atoms will absorb the radiation, and then there will be attenuation of the radiation. Now in case of photometry, there is a choice, sometimes a choice of lines, because alkaline earth metal, they form compounds which emit measurable band spectra. So since there is band spectra, there is a choice of lines is there, but in this case in AAS we have to choose a line which is which is of high sensitivity, that line to be used. AAS requires the use of resonance lines, and more for most elements there is a little choice. Line of high sensitivity is required. Now in this case, mostly filter are used. Flame photometry, we have seen that filters are there, whereas in the case of AAS we have monochromators. Monochromators are used to select the wavelength of interest. In this case, flame photometer, there is no hollow cathode lamp, there is no chopper, as excited atoms or the ions in the sample act as the source of radiation. What is the source of radiation? The excited atoms. Whereas in hollow cathode lamp and chopper is required in the case of AAS. So the differences between the flame photometry and AAS. So if we look at the application of flame photometry and AAS, so we can see that these are having application in medicines, biochemistry, and toxicology, wherein we are determining calcium, magnesium in body fluids, and sodium, potassium, iron, copper, zinc in serum. And AAS also served ideally for determination of iron binding capacity and iron hemoglobin, usually the graphite tube furnace. And application in water and air analysis, metal salts which are dissolved in water can be detected directly. AAS permitted the directly analysis of air for lead and cadmium vapors. Application in agriculture and foodstuffs, analysis of soil extracts, fertilizer, plants for sodium, potassium, calcium, magnesium, trace elements like copper, manganese, zinc, iron, molybdenum, boron. So fruits, vegetables, fish, and meat products require either wet or dry ashing. So in dairy industry, again we know that AAS is used to determine various minerals. So there is told you that AAS can be used to determine any element in the periodic table and in any type of the sample. That is the power of AAS, and that is the level to which the AAS has reached. So we have in this video we have studied about the flame photometry and seen some of the applications of AAS and flame photometry. Thank you.